All right, guys, this is the next section, 4.2, special triangles. In particular, we're going to work with isosceles triangles only. So let's recall from chapter 1 what an isosceles triangle is. Obviously, it has two congruent sides, at least two congruent sides. And there were some names or some terms that we called a couple of particular parts. So like the two congruent sides, sometimes we refer to as the legs or just congruent sides. The other side, the non-congruent side, we refer to as the base. And again, not because it's at the bottom, it's because it's the non-congruent side, okay? Because if you turn it upside down, then the base is at the top. The angles had special names. The angle between the two congruent sides is called the vertex angle. And then the other two angles are called the base angles, okay? Because the angles are next to the base. So we used those terms before, so make sure you recognize them when we use them in the homework or in the notes right now. So first investigation, it says investigate the base angles of an isosceles triangle. So what we're going to do is we're going to construct an isosceles triangle with a compass and a straight edge, and then we're going to check out what those angles look like. So first things first, let's get our compass and our straight edge. And to make an isosceles triangle, you should remember we had a section on this not too long ago. We are going to make, get a smaller pen, we're going to make any side length, whatever we want. So I'm just going to pick a random size. And then what I'm going to do to make an isosceles triangle, I'm going to put my compass on one of those endpoints. And I don't want to get the exact measure. I want it to be a little bit longer. Okay, so maybe like that. And I'm going to make an arc up at the top. Okay, and then I want to make one more arc over here. And I notice I didn't change my compass setting. I just left it the exact same measure. So now to make the actual triangle, since I use the same measure to make those two arcs intersect, all I have to do now is connect from there to there. And then come over here and connect. Always make sure your ruler's pretty precise. See right here, I feel like it's not. All right, so since I constructed that, that means this is congruent to that, okay? So now it says measure the base angles with your protractor. So you should have a protractor from earlier in the year. If you don't have a protractor, there's another easy way you can do that. You can check by using your compass, okay? So let me show you this way because I think most of y'all know how to use the compass, the protractor, but if you don't have the protractor, I'm gonna show you how to measure the angle here. So obviously they look like they could be equal, but let's just be for sure. We're gonna go ahead and make an arc on there. And then I wanna make that same arc over here. Again, if you have a protractor, you can just measure with your protractor. And if you don't have a protractor, this is the alternative method. So you get the width from to see how wide the angle is, and then you want to go check that same width over here. And look, it's exactly the same. Okay, so if you were to use a protractor, you would get the actual degrees. This is another way to actually measure those angles. And so they are congruent, right? So that is always going to take place if you ever have an isosceles triangle. The base angles are going to come out congruent. So that's how this conjecture goes. If a triangle is isosceles, then the base angles are congruent. Okay, I'm going to use a shortcut and use my congruent symbol. Okay, so base angles are congruent. Okay. Don't like that. All right, let's go to the next investigation. This investigation is asking, is the converse true? So remember, the converse is where you flip the hypothesis and conclusion. So you'll notice the conjecture. It says if a triangle has two congruent angles, then let's see if the converse is true. So it guides us over here on the left. It says construct AB, and then it says construct an acute angle at A, and then copy it at B. Okay, so let me get my straight edge and my compass. So what I want to do is I'm just going to make a random segment, and let's make this one a little bit larger. Okay, so let's make it a little bit larger so we have room to work with. So that's going to be my segment A, B, and it says draw an acute or construct an acute angle at A. So let's get our straight edge, and that's an acute angle. So let's just make a line like that. And it says copy that angle at B. Okay, so now let's get our compass, and then we are going to copy an angle. So you should know how to copy an angle. It's 3 simple arcs. I'm going to make an arc on the angle I want to copy, and I'm going to copy it at B. So I'm going to come over here and place it at B and make that same arc. And then come over here, remember to these two intersections, we want to measure how wide they are. Make sure you're right on the intersection. Okay, so that looks good. So now I'm going to come over here, place my compass on that intersection point, make an arc like so. And then it says make or extend both rays so that they will intersect at C. Okay, so I'm going to extend this one over here. Make sure I'm going right perfectly at the edge. And so I'm going to get my straight edge, make that line. And notice it does not intersect the other ray, so I'm going to go ahead and extend the other ray. So that way it is going all the way through. There we go, and it says to go ahead and call that point C. Okay, so that is going to be point C right there. And it says measure AC and BC with your compass. So now we want to get our compass, and it's easy if you place it at C and you get the width of A or to AC like that. So make sure you're right on the intersection. Make sure you're right there at A. And then it says compare it to BC. So I'm going to swing my compass around over here. What do you know? AC is the exact measure as BC. Okay, so those two sides are equal. So is the converse true? Yes, the converse is true because we made this angle congruent to this one. We constructed it with our compass. And when we extended those rays, that ended up making these two sides congruent. So yes, the converse is true. So if you see a triangle that has two congruent angles, then the triangle is isosceles. Okay, so if you ever have or see a triangle, they're not going to mark everything for you. You got to now know these two properties. Okay. All right, let's try one more investigation. This one is investigating an equilateral triangle. So it says construct an equilateral triangle. All right, you should be pretty good at this. We just did this one also not too long ago, back when we constructed isosceles triangles. So I'm going to draw just a random edge length. And then I want to actually measure that edge, okay, or segment, however you want to call it. I'm going to measure it exactly. And then I'm going to make an arc up here. And then I'm going to come over here to this end point. I'll make that same arc. Notice I did not change my compass setting. All right, so now get your straight edge, connect. You should be getting pretty good at constructions because we did a whole unit of this. Connect the endpoints to that intersection like we did earlier. And oh, that line's much thicker. Okay, so then we have an equilateral triangle. And it says measure each angle with your protractor or compass, okay? Now, some of y'all probably actually might know this one, okay? Because for one, a lot of y'all have a pretty good memory of the triangle sum, okay? And which we just covered again. And if all angles are, if it's an equilateral triangle, then a lot of you guys remember that all of the angles are going to be equal. Okay, and so we actually talked about that not too long ago. So some of y'all may not even need to use the protractor to measure this, and you would automatically know that each angle is 60 degrees. So what happens when all of the angles are 60? That means it is also saying that that's equiangular. Okay, so if you have a triangle that is equilateral, then it is equiangular. That's what goes in that first blank. Equiangular. Then it says conversely, so think of the converse, so we want to kind of flip that around. It says if the triangle is equiangular, so we want to put that one in the front now. And again, you may have heard me, or you may remember me saying this back in chapter 1. If a triangle is equiangular, then it is equilateral. Okay, and this only works for the triangle. It does not work for quadrilaterals or pentagon or sorry, hexagon. So it doesn't work for necessarily every single one. All right. Let's just try some example problems now with these isosceles triangles. So we have an isosceles triangle here based off of these two tick marks, okay? And I'm going to solve for the measure of angle B. So what is that measure? Now, here's what students will probably do on some cases. They'll say, oh, it's the same thing as the other one because those are both base angles, and they're just gonna write 2x plus 4. Well, you can actually solve for x and give me an actual measure. So if you are thinking to just leave it as 2x plus 4, then make sure that you don't make that mistake, okay? However, yes, this angle is the same as this one over here. So this angle is congruent to this angle. So that is also a representation of 2x plus 4. So I'm just going to write that down. And then you want to use your 180 rule to figure out what the measure of x would be. So let's use our 180 rule. I'm going to add these in my head. 4x plus 8. Does everybody see why I'm writing 4x plus 8? I'm adding those two algebraic expressions in my head. I'm going to add 25, and I'm going to set it equal to 180. Okay, so I'm going to use my algebra. And then I have right here, these two add up to be 33. And so what I'm going to do is I'm going to subtract 33 from both sides. And I'll have 4x on the left, and on the right, I'll have 147. I'm going to divide both sides by 4, and x is going to equal, not a nice simple whole number, but that's okay. Let's use our calculator. 147 divided by 4, 36.75. Okay, now that you know x, you can plug that in and solve for the measure of angle B. So I'm going to do 2 times 36.75 and then add the 4 to get angle B. So I have that number still in my calculator, so I'm just going to hit times 2 and then add 4. And so I have 77.5 degrees. So let's leave that decimal and not round. So 77.5 degrees. Okay, and that's how you do that right there. Now, Did you have to solve for x? No, not necessarily. I bet some of y'all are thinking, hi, why can't I just use the 180 rule from the beginning? Yes, but now you know that if a problem does ask you to solve for x, you can do that. Okay. All right. So let's look at two more examples. Both of these look like they are, well, let's just do one at a time. This one over here on the left, it is equilateral. So just to kind of get my brain thinking that it is equilateral, I'm gonna put those tick marks right there. Remember that if it's equilateral, it's also equiangular. So there's probably a couple of different ways you're thinking to do this problem, but I'm gonna try to give you the shortest way or the quickest way to do that. What is the measure of each angle? Each angle is 60 degrees, right? And so if each one is 60, I'm just gonna go ahead and set this equal to 60. Some of y'all might say, well, I'm gonna multiply it times 3 and then set it equal to 180. That is correct also. And you can do it that way if you want, okay? But this one's a little bit quicker. So I have x over 2 plus 14, and I'm gonna set that equal to 60 degrees. And now it's just a matter of solving for x, because that's all we need to do. So I'm gonna minus 14 from both sides, cancels out. And then I'm going to have x over 2 on one side, and 60 minus 14 is 46. And then I'm going to multiply by 2 to get rid of that. And whatever you do to one side, you must do to the other. And then that's my x. What is 46 times 2? 92, right? Just to be sure. Let me check. Yes, it is. It's 92. So x is 92. Now, some people freak out and say 92, there's no way an angle can equal 92. It's not the angle that equals 92, it's the value for x, okay? All right, one more. It says find the perimeter of this thing. Okay, well, you see these arcs here in each angle. That's signifying that these three angles are congruent. So if each angle is congruent, then that must mean that each side is congruent, right? And so if each side is congruent, and I need to find x somehow so I can find the perimeter. You don't want to have your answer in terms of x. I know some of you, it's kind of like what I stated earlier. You don't want to leave your answer in terms of x. So let's go ahead and figure out how to do this. So if they are all equal, you want to kind of set this expression over here equal to this one. You don't want to set 2x equal to 2x because that won't get us anywhere. So this side is congruent to this side. So let's do some algebra. So 5 over 2x minus 5 is equal to 2x. All right. So I have x on both sides. Some people probably thinking, well, what is the measure of 5 over 2x? Well, how many times is 2 going to 5? So some of y'all can think of that as 2.5x minus 5 equals 2x. Okay, if you don't like fractions. And so what you can do is, I don't like working with negatives. I know some of y'all say, well, subtract 2.5 from both sides. I'm going to subtract 2x from both sides, and then I'm going to add 5 to both sides. So yes, it was an extra step, but it doesn't have any negatives that I have to worry about. So 2.5x minus 2x is 0.5x. And that is equal to 5 over here. So I just have to divide by 0.5, and it's okay to divide by a decimal. X is going to equal, how many times does 0.5 go into 5? If you put it in your calculator, it'll spit out 10 for you. Okay, so now I have x equals 10. That's an easy plug-in to that one right there. So if you plug in 10, the measure of each side will be 20 centimeters. So if each side is 20 centimeters, 20 times 3 is 60 centimeters. And that is it for isosceles triangles.